In this video, we want to take a look at where the formula for the sum of a geometric series comes from. So to do that, we're going to take a look at a specific example, this one right here, to see where does the actual formula come from. So first, let's make sure we know what this series looks like. So the first term is 4 because n is 1, and 1 minus 1 is 0, 3 to the power of 0 is 1, and 4 times 1 gives us 4. Then n becomes 2, so 4 times 3 squared is, 3 to the first is 12. Then we're just multiplying by 3 over and over again, our common ratio. So 12 times 3 is 24, 24 times 3 is 72, and so on and so forth. And we're going all the way up to the 99th right here because we're doing 100 terms. So 100 goes in for n. 100 minus 1 gives us that 99. So 4 times 3 to the 99th, it'd be a massive, massive number. Your calculator might not even be able to do that. So what we're going to do to figure out what this sum equals, I'm going to call it S. We're going to rewrite it. So I'm going to space it out a little bit. So our first term is again 4. But now where does the 12 come from? The 12 came from 4 times 3 to the first power. And the 24 came from 4 times 3 squared. The 72 was 4 times 3 cubed. I think I got off one. That's the 24 right there. No, that's the 72. All the way to 4 times 3 to the 99th power. So I just spaced it out there. Doesn't really help us find the sum yet. But then somebody came up with a brilliant idea. They took this S and they multiplied it by the common difference. The common ratio. All right. So 3 times S. So that means each of these terms is going to get multiplied by 3. So the first term becomes 4 times 3 to the first because we're multiplying this term times 3. The next one, multiplying by another 3, so it becomes 3 squared. Then 3 to the third, then 3 to the fourth, and so on and so on. And so the last one now becomes 4 times 3 to the 100th. The next brilliant thing they did was they took that whole row and they shifted it over 1. So this term is going to get shifted over to here. This term is going to get shifted over here. So every term just gets moved one space to the right. All right. So now everything is lined up. Moving it over 1 didn't actually change what it equals. We're just realigning things. So then what they realized is we can take these two equations and subtract them. Okay. So the left side, we're going to do our sum, which again, that's what we're trying to find, minus 3 times our sum. So we're just subtracting this down. If you do it to one side, we got to do it the other side. So we're going to subtract these. So 4 minus nothing is just 4. And here's where the amazing part happens. These two terms are the same, so when we subtract them, they go away. These two terms are the same, so they go away. That goes away. All the stuff in the middle goes away. This term goes away even, and you're just left with one more at the end. So plus, not plus, minus, because remember we are subtracting. We are subtracting minus 4 times 3 to the 100th power. So now this infinitely long addition problem is no longer infinitely long. So now we just have a little bit of algebra to do to clean this up, to figure out what S actually is. So on the left, we realize that there are two terms and they both have an S. So we factor that out. S is right here, parentheses, 1 minus 3 equals, and on this side we see that these two terms both have a 4. So we also factor that out. 4 times, all right, you're left over with a 1 minus, the 4 goes away, you're left with 3 to the power of 100. So you want to know what S is, so I mean you have to get rid of all of this. I'm not even going to simplify, I'm just going to divide by what's there. It's multiplying, so we're going to divide both sides by 1 minus 3. If I do it to one side, I have to divide the other side. 1 minus 3. So this goes away. You're left with just S on the left. And on the right, you have 4 times 1 minus 3 to the power of 100 divided by 1 minus 3. So let's take a look and make sure we know where all this came from. The 4 was our first term. The 3 to the 100 power was imagining if we went one more term past this one. All right, remember this is n minus 1. Our formula just has n. And then 1 minus 3, the 3's came from our common ratio. All right, so that's kind of where the formula comes from. Hopefully you can do that on your example as well.